Type third integral. As we seen in type 2, if numerator is 1 and denominator is the linear term of sin x and cos x. Now in type 3, the denominator is a term of quadratic form of sin and cos, like sin square x and cos square x instead of sin x and cos x. Such a form is called type third. See the form. If the term is only in sin square x or in only in cos square x or in both sin square and cos square. For this type of form, we have to divide numerator and denominator, as here numerator is a 1 and denominator is in addition. So divided numerator and denominator by cos square x, and by putting tan of x is equal to t, we can evaluate the integration. You can define type third example as you seen here in examples, as there is a numerator is a 1 or dx and denominator contain term of sin square and cos square in addition or subtraction. Such a type is called standard type of integral, type number 3. Now the first example, as we see, denominator contain term of sin square and cos square in addition. So by using dividing numerator and denominator by cos square x, we can get I is equal to integration of, as numerator is 1, so 1 divided by cos square x. As in denominator there is a addition, so dividing denominator by each term separate by cos square x. The first term is a 4 cos square x, so we divide 4 cos square x divided by cos square x. Second term is a 9 sin square x, so we divide 9 sin square x divided by cos square x and multiplied by integral dx. So as we know, 1 upon cos is nothing but sec, so 1 upon cos square is a sec square x is in numerator, and in denominator, as in first term cos square get cancelled, so we get 4, plus in second term sin square by cos square get cancelled, and sin square by cos square r is a tan square x, so we get 9 tan square x. Now see the denominator, in which we are check the term of tan square x. Now we have given that put tan x as a t in integral. Now by using its differentiation with respect to x, we get sec square x dx is equal to dt. Now in integration, as the term of tan x is replaced by t, so tan square x will become t square, and in numerator sec square dx, which is become dt. So integration I will become, I is equal to integration of, as we put tan x in denominator, so we put first numerator as a 1, and in denominator the first term is a constant 4, so it remain as it is, and second term will become 9 t square. Now sec square dx is a dt. So the after substitution we get the integral, which is in form of radical function. As you can see, here is a 1 in numerator, and denominator is a quadratic term of t, in which t it is a free of t terms. So by standard integral we can evaluate this, but for that we have to make coefficient of t square is equal to 1, so we can take 9 common in denominator, as 9 is a constant, so we take it outside integration. So outside integration we get 1 by 9, and in numerator 1, denominator first term will be 4 by 9, as 9 we take 9 common, and second term will be t square dt. Now make the constant in denominator in form of square, so 4 by 9 will be square of 2 by 3 t square into dt. Now using the radical form, as we can see here, addition is there, so a square plus x square is the form, as integration of 1 upon a square plus x square, or x square plus a square is always 1 upon a tan inverse of x upon a plus c, as here a is a 2 by 3 and x is a substituted by the variable t, so it's so integration of this integral is 1 upon 9 into 1 upon a, that is 2 by 3 into tan inverse of t divided by a 2 by 3 plus c, and finally we have to resubstitute value of t, as we put t as a tan of x. Okay, so answer will be, as here 9 into 3 into 3 9, 3 into 2 6, 1 by 6 tan inverse of the value of t is a tan of x divided by 2 by 3 plus c. I is integration of 1 upon 3 minus 2 sin square x. As we see here, sin square x is given. In this example, we make one simplification by using identity first of trigonometry, which is 1 is equal to sin square theta plus cos square theta, or sin square x plus cos square x. Now here in term of constant, in denominator 3, we can simplify 3 into 1 or 3 into sin square x plus cos square x. Remember this step, and minus 2 sin square x is given, so into dx. So understand the steps. Actually in constant 3 is given, we take 3 into sin square x plus cos square x. Now simplifying this bracket multiplication, so we get 1 integration of 1 upon 3 sin square x plus 3 cos square x minus 2 sin square x. Now again adding term of sin square x, so 3 sin square plus 2 sin square, we get sin square x, and plus 3 cos square is remain as it is. Now check, this is like the integral which we solved already in example number 1, that is 1 upon 4 cos square x plus 9 sin square x. So remember this step. Now remaining steps are as we seen in first example. First divide numerator and denominator by cos square x. So in numerator we get 1 upon cos square x, and in denominator, as there is a addition, we can take separate integration or separate division by cos square x of each term. So in second term we get 3 cos square x divided by cos square x into dx. As we know, 1 upon cos square is always sec square x, which is in the numerator, and in denominator in first term sin square by cos square will replaced by tan square x as by relation of trigonometry, and in second 3 cos square get cancelled, we get only 3. Now next step, by putting tan of x is equal to t, we continue here. Tan of x is equal to t, and its differentiation with respect to x is sec square x, which is in numerator, in multiplication of dx. So we can make integration I is equal to, as we are putting tan x in denominator, so we put numerator as a 1, as here is a tan square x, as tan x is equal to tan square will be t square plus 3 is a constant remaining, and sec square dx will be dt. Now see, this is again a radical form of which the coefficient of t square is 1, so we have to make only constant in term of square. So 1 upon t square plus 3 is the square of root 3. Again we are going to apply the same radical function formula, 1 upon x square plus a square, which has the integration 1 upon a tan inverse x upon a plus c. Here a is root 3 and x is replaced by variable t, so integration will be 1 upon root 3 tan inverse of t upon root 3, and final step we have to resubstitute value of t, which is value of t is a tan of x. Therefore tan of x divided by root 3 plus c. I is equal to integration of 1 upon 2 plus 3 cos square x. As you can see here, again the denominator is a contain only term of cos square x in addition of constant 2. So we are going to make simplification by putting 2 as a 2 into 1, and 1 will by 1 is replaced by trigonometry identities sin square plus cos square, and second term is remain as it is. Now we can simplify the bracket multiplication too, so we get in denominator 2 sin square x plus 2 cos square x plus 3 cos square x is as it is. Now the term of cos square are added, so in denominator we get 2 sin square x plus 5 cos square x into dx. Now see, again the form which we already evaluated in integration number in example number 1. So dividing numerator and denominator by cos square x, in numerator as 1 divided by cos square x, and in denominator again we get addition, so separate separate each term divided separately by cos square x. So in first term we get 2 times sin square x divided by cos square x, in second term 5 cos square x divided by cos square x. And simplifying, as we know 1 upon cos square is always sec square x, and in denominator 2 sin square x divided by cos square will become 2 tan square x plus cos square get cancelled, and we get the integration in for 5 sec square x divided by 2 tan square x plus 5. Now we can make substitution as tan of x is equal to t, so its differentiation with respect to x will become again sec square x dx is equal to dt. Therefore integration in term of t become, as we putting in denominator, so numerator become 1 and in denominator 2 tan square x, again tan x is equal to t, so tan square will become 2t square and plus 5 is a constant and sec square dx is a dt. Again we get the same radical form in which t square coefficient is a 2, so we have to make it 1 by taking 2 common in denominator, as it is a constant, so we take it outside integration, so in integration 1 upon t square plus 5 upon 2 into dt we get. Now make the constant in term of form of square, so 5 by 2 is the square of root of 5 by 2. Okay, and finally apply the same form of integration, 1 upon a, which has integration 1 upon a tan inverse x upon a plus c. Here a is the root 5 by 2, so 1 upon root of 5 by 2 into tan inverse of variable t divided by again a root 5 by 2 plus c. And finally we can simplify 2 by 2 into root of 5 by 2 into tan inverse of, by resubstituting t, tan of x divided by root 5 by 2 bracket complete plus c.